Hi there. Thank you so much for joining the Hadoop in Real World course. We are very excited to have you in the course. Our goal is to make your learning experience in this course as easy as possible. Please remember, we are here for you. If you have any questions or doubts or concerns, please let us know and we will be happy to address them. The best way to reach us is by adding a discussion in the course. You can find the Add Discussion button to your right-hand side to add a discussion. You can ask your questions or doubts there. From the very first minute of designing this course, our goal is to help our students get most out of this course in the most efficient way as quick as possible. For example, think about this. Would you learn to build a guitar first when you're learning to play a guitar? No, you wouldn't. So why waste time and effort to set up Hadoop cluster to practice Hadoop? It's not efficient, right? Hence, for that reason, we provide a personal account to a real 3-node Hadoop cluster hosted on Amazon Cloud along with this course. You can also see the same efficiency in our course structure. Most of the courses teach cluster setup at the very beginning of the course, and it is probably the worst thing to do because at this stage, students are not fully aware of all the components and architecture of Hadoop. So for this reason, in this course, you will see cluster setup chapter after we have covered all the essential topics. Okay, now let's talk about the high-level structure of the course. We will first talk about what is big data, complexities that involve in analyzing big data sets, and how Hadoop proposes a solution to the big data problem in our introduction to the big data chapter. Next, there are two main core components in Hadoop, HDFS and MapReduce. We'll learn about HDFS first and then we'll learn about MapReduce in the next chapter. Then comes two most important tools in the Hadoop ecosystem, Apache Pig and Apache Hive, in separate chapters back to back. Before we proceed to set up a Hadoop cluster, we need to be very familiar with the architecture of Hadoop. So we'll cover architecture first and then we'll move on to cluster setup. Now we are ready to move on to some advanced concepts. In the next chapter, we'll look into different file formats. A Hadoop course is not complete unless we talk about troubleshooting and optimizations. So we'll cover that next. Finally, we'll have a bonus chapter. Now let's look at each of the chapters in detail. Let's look at the introduction to big data chapter. Before we learn about Hadoop and its core components, we want to understand what is big data and what is the real problem with big data. When we understand the problem, we move on to see the solution, which is Hadoop, and how it proposes a solution to the big data problem. We'll also see a brief history of Hadoop in this chapter. File systems are not new. There are several file systems available already. So, in the HDFS chapter, we'll start by asking a very simple question, which is the need for another file system like HDFS, when there are many file systems already available. Once we understand that, we go in detail about the importance and significance of HDFS blocks and we'll learn to work with HDFS. Also in this chapter, we'll see the internal workings of read and write to HDFS, and we'll also see how we can read and write to HDFS by writing our own Java program. Along the way, we'll look at the concepts like data locality, replica placement, etc. Distributed processing in Hadoop is made possible by MapReduce. In the next chapter, we'll first go over the MapReduce phases in detail, then we'll learn all the components that make up a MapReduce program. Next comes the exciting part, which is writing a MapReduce program. We'll use our stocks dataset to perform some meaningful analysis using MapReduce. We will then learn about the nuances involved with combiners, then we'll see the benefits of counters. Then comes two important and interesting projects. First project is inspired by Facebook's mutual friends functionality. In this project, we'll take an abstract concept like finding common friends between two friends using MapReduce. Also, we'll see how to write custom writables in this project. Next project is inspired by New York Times Time Machine project. We'll convert a lot of files into PDF files in this project in a distributed fashion by writing a MapReduce job. This is an advanced project, and in this project, we'll cover writing our own custom input-output formats and writables, all in one project. At the end of this chapter, you'll be fully comfortable with using a Hadoop cluster, and also you will know how to write and execute MapReduce programs in a Hadoop cluster. Writing a MapReduce program takes some time and effort, so tools like Apache Pig and Hive make it much easier to write MapReduce program with simple instructions or queries. In the Apache Pig chapter, we'll start by understanding the need for Apache Pig and we'll learn to write pig-laden instructions. We will learn to load dataset with simple and complex types and join dataset to produce meaningful output. There are two projects in this chapter. The first project is an interesting project in which we'll use a dataset named Million Song Dataset, which has metadata for about million songs, and we'll find less familiar artists with hot songs. Sounds interesting, right? In the next project, we'll rank pages from a dataset that we'll extract from Wikipedia. The dataset will be in XML format. This is an advanced project because we'll write a custom input format to read the XML dataset and write a pig load function to load the dataset, and then we'll write pig instructions to rank the pages in the dataset. Now moving on to the next tool. SQL is the most powerful tool to analyze data in databases. Hive offers SQL capability in Hadoop. In this chapter, we'll learn to create tables in Hive, and we'll start with writing some simple HiveQL queries in Hive. We'll learn the differences between managed and external tables. Next, we'll learn how to organize the dataset efficiently for faster processing using partitions and buckets. Finally, we'll stream live tweets from Twitter, and we'll learn complex types with the Twitter dataset. At this stage, you know how to work with Hadoop with two most important and must-know tools in the Hadoop ecosystem, Apache Pig and Apache Hive. To install a Hadoop cluster from scratch, we need to understand the architecture of Hadoop in detail. In the next architecture chapter, we'll go in great detail about Hadoop's architecture, starting with the architecture of HDFS. Architecture of MapReduce is different in legacy and in the latest versions of Hadoop. We have to understand both architecture because some production clusters are still on the legacy architecture. So we will learn both architecture. Architecture in MapReduce 1 are MRV1 and architecture in MRV2 are YARN, short for yet another resource negotiator. Failures are unavoidable in any software framework, and hence we need to acknowledge potential failure points and should be prepared when things go wrong. Hadoop has few single point of failures. We'll see what those failure points are and we'll see how to recover from failures. We'll talk about secondary name node, checkpoint, and standby nodes, and we'll learn how to make Hadoop highly available. Now we understand the architecture of Hadoop and all the necessary components involved in operating a Hadoop cluster. In the cluster setup chapter, we'll learn about Hadoop distributions and hosting solutions to host our own Hadoop cluster. Next, in a series of lessons, we'll install a 3-node Cloudera CDH version 5.4 Hadoop cluster on Amazon Web Services on EC2 instances. At the end of this lesson, you will be able to set up your own Hadoop cluster on Amazon Web Services. We have two advanced chapters next. Most courses out there teach Hadoop without providing students any exposure to different file formats. Most Hadoop production environments deal with dataset which are not just text in nature. So file formats chapter is very important. In this chapter, we'll learn about compressed files, the issues and problems involved in compressed files. Next, we'll learn how to store binary data using sequence files. We'll also see how to address small files problem using sequence files. Next, we'll see how to create a dataset with inter-program operability using Avro. In other words, we'll create an Avro dataset in Java and read the dataset using Python. We will learn to use these formats with plain MapReduce programs and also with Apache Pig and Hive. A Hadoop course is not complete until we learn about troubleshooting and optimizations. We will see exactly that in the troubleshooting and optimizations chapter. The concepts we'll learn in this chapter will come in handy when things go wrong, meaning we'll learn to troubleshoot and debug issues, along with we'll learn techniques to optimize slow running jobs. Furthermore, we'll learn how to write optimized Pig and Hive joins by understanding how joins work behind the scenes, and also learn how to use hints to write optimized Pig scripts and Hive queries. At this stage, you have mastered a lot of concepts in Hadoop. It is time to get your dream career in Hadoop. We have a bonus chapter, In this chapter, we have a lesson that will help you prepare for Hadoop interviews by providing some valuable pointers and tips to find Hadoop job openings, preparing a resume, and even has some actionable tips to help you prepare for Hadoop interviews. Sounds good, right? And one final thing. We recommend you go through the course as it is laid out. But if you're more interested in the architecture and cluster setup chapters, there is a shortcut. Right after the MapReduce chapter, you can move straight on to the architecture and cluster setup chapters, skipping Apache Pig and Hive chapters, and then come back to Apache Pig and Hive chapters later. Note that Apache Pig and Hive chapters are prerequisites for file formats and troubleshooting and optimization chapters. So you need to finish Apache Pig and Hive chapters before you proceed with file formats and troubleshooting and optimizations chapter. In the next lesson, we'll go over the tools and setup you need to have to proceed with the course. See you in the next lesson.